So here also I give you another example regarding the curl or divergence. So look at the grade. This is a test 2 on 17-19 semester 1. So here okay, we are given a vector field F, and F is irrotational, which means that the curl F is 0. So from that information, you have to find the value of ABC for the given F here. So meaning that what is the curl F? So grad cross F. So first you have to find the grad cross F. Okay, so let me copy the F first. Okay, so these are the F, and then the curl of F. So from here, so the component I, J cross K. So you have to differentiate this with respect to I, 0 plus C plus 0. So you just have C. And then for Y component, sorry, for Y or J component, you have to differentiate this with respect to Z. So you have just a second. So this one is not complete yet, right? So this one 0 plus C plus 0, and this one minus, differentiate this with respect to Z, you will have negative 1, so plus Z. Okay, and then for this one you have to differentiate with respect to Z, so you have minus, differentiate this with respect to X, so only this, so you have 4. And the third one, I cross J. So differentiate this with respect to X, you have B minus, differentiate this with respect to Y, you have 3. Okay, and since the information provided says that the curl of this F is 0, which means that from that information, this part should be 0, this one should be 0, and this one should be 0. So then it's come to the answer where for the first component you have C plus Z equal to 0, and then we have A minus 4 equal to 0, and we have B minus 3 equal to 0. So here we have A equal to 4, B equal to 3, and C. Okay, how can we have Z there? Am I did something incorrectly? Let me check first. Okay, I found that this is not Z. You have to differentiate this. Differentiate this with respect to Z. So the answer should be negative 1. So plus 1, not Z. 1. So this one is 1. So C is minus 3. So that is the answer. Then that will give you 6 marks. Okay, 6 marks. Okay, another question, another exam-like question. So this is from previous test. So okay, you are given a vector field which representing the fluid flow. So the first question, find the divergence of the given vector field. Okay, so okay, let me copy first the F. Okay, so you have to find the divergence of the given F. So you can have the del x of xy plus del y of minus xy plus del z of y squared. Okay, and you will get y minus x 0. Okay, so that is your divergence. So the second question, you will get this one. Okay, which means that you have to differentiate this with respect to x, you give y, differentiate this with respect to y, you got minus x, and differentiate this with respect to z, and this is 0. Okay, and the second question, calculate the divergence of the f at the point 1, 2, 3, and give the interpretation to the value. So, if we remember about the divergence, so it will tell you if the divergence positive, whether it's source, or sink, or incompressible, right? Okay, so now we want to look at this one at the point. So the second question, the divergence of f at the point of 1, 2, 3. 1, 2, 3. So y minus x, so y is 2 minus 1, so the answer is 1, which is positive. So if we look at the notes, let me check where is my notes. Second. So based on your result, your divergence is positive. So you can see that the point of, so the point of 1, 2, 3 is a source point. Which means that if you're, because the question just now say that we have the fluid flow, right? So meaning that the point of 1, 2, 3 is become the source point. Just like you imagine you have the water tap, okay, water tap, and then you open, right? You open the water tap and all the, the water coming out. So that tap, the water tap is called the source point. So yeah, because water is coming out from the water tap. Okay, but if you have a sink point, just like you have a sink at the kitchen, you have a sink. So all, imagine there are a lot of water in the sink, and in the sink there is a hole, right? So all the water will flush in through the hole in the sink. So we call that as a sink point. So if we look at the third question, identify the location where the fluid is incompressible. So meaning that the word here, the hint here, there is the word incompress, and we want to relate this with the divergence. So what is the property when we say that the fluid is incompressible? So our divergence is equal to 0. So from the first result, we already obtained that the divergence of that fluid flow is given by y minus x. So if we want to say that the fluid flow is incompressible, so the divergence should be equal to 0. Okay, so in this case you can say that y equal to x, and then the question here asking for identify the location where the fluid is incompressible. So you can say that, okay, back the question, identify the location where the fluid is incompressible. So the fluid is incompressible. So the fluid is incompressible on the y equal to x plane. What does this mean? Okay, so look at here. We have a 3D or 2D. Okay, so based on the information provided, we have the IJK, which means that the fluid that we have here is on 3D. So by using the result from the third question, so this is from the third question. So to be compressible, the value of x should be always equal to y. Okay, so for any points, x always equal to y. But how about z? Z can be any number as long as the value of x is equal to y. So in general, we can say that the fluid is, because the question here identify the location, which means that if you're thinking about a single point, so we can say that that point should be any points as long as the y and x value they are the same. But if you combine all together, you have infinitely many points, then you have a plane where for any z, then your y and x should be the same. So it looks like if we sketch that point of y equal to x plane, do you remember how to sketch the 3D graph? You should provide the trace. So the trace on y-x plane, so y, x, and you have the line, and you have y equal to x. Okay, so xy can be negative, can be positive. So now that is trace, and then you convert to 3D. So this is your maybe I want to just fix the orientation here. Y, and this is x, and this is z. So then what I can draw there is I have the y-x, so I have this line, and should be the line over here where it looks like because okay, maybe I should change, otherwise it'll be confusing. So maybe this one. Okay, and then I have to do a projection. So to do the projection, it's better for me to increase this. Okay, so this is sec. So then you assume that you have another y-x, and you draw the similar line and should parallel each other in that one. Okay, and then what you have to do is to complete the plane. So that line is parallel to z, and that line is parallel to z. So that is your plane. So meaning that if we want to answer this question, identify the location, so meaning that any points which are lying on this plane for any z, as long as the point is y equal to x, they are always the same. Okay, but other than that, let's say you choose a point over here, so that it's not considered that the fluid is incompressible. To make sure that the F is always incompressible, so should be lying on this plane. Okay, so that is the idea.